come to my own conclusion earlier on. I had thought, well, because I was a ski instructor and I climbed as well a lot. I love climbing. And I was in nature all the time. I thought, well, if I want to know the structure of the vacuum, if I want to know the structure of space-time at the vacuum level, and if nature is being directed by that structure, I should be able to observe nature and see it. I should be able to deduct it from a good observation of nature. So I was always looking at snow crystals, and when I was climbing at the crystals on the rock, and I was always looking at things and the way branches divides in a tree and all this. And I had come to conclusions that the universal forces, the vacuum division, seemed to always generate a very fundamental, specific geometry, and that geometry was the geometry of a sphere. It makes spheres, little spheres, and bigger spheres, and then assembles them together and gets all sorts of things. But I was thinking, wait a minute, though. The sphere would be the part that's on the outside. The sphere would be the event horizon. The sphere would be the boundary from which things radiate. What I want to know is what's inside that. I want to know what's the geometry that holds the sphere together. How does the sphere pop out in the vacuum? And it wasn't obvious, but I started to study geometry, and I realized that the sphere is the most unstable geometry. It's got the most surface, and it doesn't have structure, so it's the most unstable geometry. So how would it hold together? And I thought, well, it has to have the most stable structure in the middle. And not only would have to be the most stable structure in the middle, whatever the structure was that was holding the sphere, that was dividing the vacuum, that structure had to be in perfect equilibrium. Because it had to be able to be observed as the vacuum. That is, if it had infinite amount of density, at the end of the day, when all the density, all the vectors of the geometry would collide at that level, the geometry that would result would have to be in perfect equilibrium so that we would think that it's empty space. That we would think that it's a vacuum. So all that logic had come through, and so I started to study what would be the smallest, the most stable, the most equilibrium geometry I could find. And what I had found is that the exact opposite of the sphere, which is the largest and most unstable, was the tetrahedron. And if we look at a tetrahedron, it's made out of, it's the smallest volume possible, okay, with equal edges and equal faces. And it's made out of 3 faces on top and 1 on the bottom. So 4 faces generates, it's like a pyramid with a triangle base. And this is actually the most stable, fundamental, and the most fundamental geometric structure we can find in nature or in geometry. So I thought, well, okay, it probably has something to do with the tetrahedron inside a sphere. And I had come to those conclusions. So I didn't know why all these ancient people were building pyramids. But I thought maybe when I go home, I'll study it and research a little ancient text and stuff like that. So I go home. I'm living in Whistler, right? And I, went to my local library, which wasn't much. I mean, this is a ski resort. And I'm looking around, and this book pops out at me, and it's called Mystery of the Mexican Pyramids by Peter Tompkins. And I thought that was an appropriate title because I really felt there was some kind of mystery going on there. So I pulled out the book and I opened it randomly, if there is such a thing. And it opened on page 280, I believe. And it had this graphic on it. A tetrahedron inside a sphere. This was the first time I was starting to study ancient texts, and that's the first thing I found. Actually, the solution that I had come up with my own logic and my own geometry and my own math on my own. So I started to read, and I got the original papers, and I realized that this graphic came from the result of a 20-year investigation of the plaza and the pyramidal structures that are found north of Mexico City. And it has the moon pyramid, the sun pyramid, and the person that did the survey there, did it for the American Society, is known as Hollison Jr., I believe. And he came to very amazing conclusions. First of all, when he started to map the whole city at Teotihuacan, he found that the sun pyramid and the moon pyramid and all the other buildings seems to be in appropriate relationship to each other, so to reproduce a map of the solar system, including Pluto and Neptune, which were planets that we didn't discover in modern age until the early 1900s. So that was very amazing to him that these people would have that knowledge of that. It was very compelling. And he started to, he spent 20 years there surveying the whole thing, and he started to find that there was very specific racial relationship between the buildings and how they were placed and mapped and all this around the world and around the whole city. And he thought, there's some kind of fundamental code that's being used here to build all this, and maybe there's some kind of fundamental message. And after 20 years of research, he delivered his papers to the American Society, and in it, he mentions that according to his mathematics and the way he mapped this, it seems that everything seemed to be pointing out that we should be looking, or that the mathematics that they use had to do with a tetrahedron inside a sphere. This really stunned me. It was amazing. I mean, I thought I was going to copyright that stuff, and somebody had come up with it a few thousand years before me. It was right there in this book, and so that really got me going in studying ancient texts. But more importantly at the time, there was a comment that was made in that book that the fundamental equation that Hugh Hollison Jr. used to map this out matched a very specific mathematics of Buckminster-Fuller, which related to an isotropic vector metric. And the isotropic vector metric is made out of 20 tetrahedrons. There's 10 on the bottom, 6 on the second level, 3 on top, and 1 on top. It's actually a 4-frequency isotropic vector metric. This fundamental geometry was part of Bucky's concept that the universe had a mathematical geometric blueprint to it, so something very similar to my thoughts, and that blueprint related to this very specific metric. So I got very excited and I started to study it in detail.